Good afternoon. Let us start our lecture today. So today we can continue with the wave equation. So we're gonna solve the following problem. UTT is equal to 4 times UXX. So in this case, x is from 0 to 2, and t is from 0 to infinity. And then you have ux at 0, t is 0, u at 2, t is also 0, and ux at 0 is 1 minus x squared over 4, ut at x is 0 is going to be 0. Right, so this is, today we continue with the wave equation. All right, so this is a wave equation because you have the second derivative in time of u, second derivative in x of u. The equation is for x from 0 to 2, for t from 0 to infinity. We have two boundary conditions, right? ux at 0 is 0, u at 2 is 0. You have two initial conditions. Ux at 0 is 1 minus x squared over 4, and ut at 0 is 0. Right, so the first step is to find the basis by solving the eigenvalue problem. You're gonna solve phi second is equal to lambda phi, so phi is only a function of x. So here u is a function of ux and t, and phi is a function of x only. And so you're gonna solve it from 0 to 2. What are the two boundary conditions for the eigenvalue problem? Yes?
Ux of 0t is 0, u t 2t is 0.
Yes, can you stand back a bit, please? So you're going to take this boundary condition, right? You just remove the t and you replace it by phi. So what you do is you're going to have u prime at 0 is going to be 0, and u at 2 is going to be 0. All right? So what you do is that, okay, so this is the boundary condition for x. What you do is you just replace it by replace the t, right? And then u at 2, t is 0. So you also remove the t and you get phi 2 is 0. And this is the eigenvalue problem that you need to solve. All right? Yes?
Isn't it like formatted like UTX? So shouldn't those like coordinates be swapped in the boundary and initial condition? It shouldn't be like UXT, 0.
So here I get uxt. U is uxt. Alright, so it's the same. So I change, I just wipe accidentally, but it's the same function, right? So u is uxt. So in this case, u at 0, meaning that x is equal to 0, and x at 0. So this means that this is 0, right? Now I have to solve the eigenvalue problem, right? So phi second is lambda phi. For x is from 0 to 2, and phi prime at 0 is 0. Phi 2 is 0. So how can we solve an eigenvalue problem? Yes?
What gives us that characteristic equation that
Yes.
is squared?
Can you stand back paper, please? So you look at the characteristic equation, right? So the characteristic equation will be r squared is equal to lambda. Case number 1, lambda is positive. What happens when lambda is positive?
We have
Yes?
two solutions.
What are they?
Each of which are square root of the number
Yes, can you stand back paper please? So in this case we have two roots. Two roots for the characteristic equation. So R1 is the square root of lambda and R2 will be minus square root of lambda. Alright, so in this case what is the form of the solution? Yes?
C1 e square root lambda t or x in this case plus C2 e minus lambda.
Yes, can you say back up paper please? So in this case you have Vx will be C1 e square root of lambda t x plus C2 is minus square root of lambda x. Right, so what is the next step? Yes? Yes, can you send back paper please? So I'm gonna use the boundary condition that phi prime is 0 is 0, right? So because phi prime is 0 is 0, I have to compute the derivative of this guy. What is the derivative of this guy? Yes?
Square root of lambda, or C1 square root of lambda equals square root of lambda x plus C2, or minus C2.
And stand by paper please. So you put square root of lambda C1 is square root of lambda x plus minus C2 square root of lambda is minus square root of lambda x, right? You compute the derivative of this guy. So the derivative of this guy gives you square root of lambda C1 is square root of lambda x minus C2 square root of lambda minus is minus square root of lambda x, right? So now I plug phi prime is 0. So this is 0, but this is also equal to square root of lambda C1 minus C2 square root of lambda, right? I plug the first boundary condition into this equation. I find phi prime is 0 is 0, which is also square root of lambda C1 minus C2 square root of lambda. What can I say about C1 and C2? Yes?
C1 equals C2.
Yes, can you stand back please? So in this case, you have C2 is equal to C1. The form of Px will be C1 is square root of lambda x plus C1 is minus square root of lambda x. Right? And what is the next step? Yes? Yes, can you stand back please? Right, so you're gonna plug the second boundary condition here, right? So the second boundary condition is phi2 is 0, which means that C1 is square root of lambda times 2 plus C1 is minus square root of lambda times 2 is equal to 0. So from here, what can I say about C1? Yes? Yes, can you stand back please? So which means that C1 is also 0. So in this case, we don't have anything. All right? It's clear? So case number 2, lambda is 0. So what happens when lambda is 0? Yes?
You have a double root and I have to use AX plus B.
Yes, can you stand at the back of the paper, please? So in this case, phi second is 0, right? Because phi second is 0, you're going to have phi x will be ax plus b. Next step is what? Yes?
Use the boundary conditions.
Yes, can you stand back for please? So now you want to use the boundary condition, right? Because the first boundary condition involves derivatives. So here I have phi prime is x. It's a. So phi prime is 0, which means that a is 0. Right? So because lambda in this case is 0, when lambda is 0, phi second is 0. Phi second is 0 means that phi has to be able to form ax plus b. You plug the first boundary condition, you get a 0, so phi x should be b. So what is the next step? Yes?
Plug in the second boundary condition.
Yes, can you stand back paper please? So now you're gonna plug the second boundary condition. So phi2 is 0, which means that b is also 0. right? So in this case, you don't have anything either. Case number 3, lambda is negative. So what happens when lambda is negative? Yes?
Your root would be plus or minus 5 times the square root of the absolute value of lambda.
Yes, can you stand back paper, please? So in this case, the two root will be I plus or minus square root of the absolute value of lambda. So what is the form of a solution in this case? Yes?
The C1 times cosine square root of absolute value of lambda times x plus C2 sine of sine of square root of absolute.
Yes, can you stand back paper, please? So Px in this case will be C1 cosinus of the square root of lambda x plus C2 sinus of the square root of lambda x. Alright? It's clear? Right, so what is the next step? Yes?
You take the derivative and plug in the value.
Yes. Can you stand back paper, please? So now I'm gonna take the derivative of this guy because I want to use the first boundary condition. So you have minus C1 square root of lambda sinus of square root of lambda x plus C2 square root of lambda cosinus of the square root of lambda x. Right? I'm gonna take the derivative because of the first boundary condition. So if x is of this form, so derivative of this guy gives me minus C1 square root of lambda sinus square root of lambda x plus C2 square root of lambda cosinus square root of lambda x. Right? So the first boundary condition is phi prime is 0, which means that minus C1 square root of lambda sinus of 0 plus C2 square root of lambda cosinus of 0 is 0. Right? What can you say about this condition? Yes?
C2 equals
C2 is equal to 0. Yes, can you say back paper, please? So this guy is 0 because sinus of 0 is 0. This guy is C2 square root of lambda is 0, which means that C2 is 0. All right? Right, so because C2 is 0, phi x in this case will be C1 cosinus of square root of lambda x. Now what is the next step? Yes?
under the boundary condition.
Yes, can you send back paper, please? So now you have phi2 is 0, which means that cosinus of the square root of lambda times 2 is 0. All right? What can I say about lambda? Yes?
You know, square root of lambda times 2 equals n pi plus pi over 2.
Yes, can you send back paper, please? So here you have square root of lambda is n pi plus pi over 2. All right? Which means that square root of lambda will be n pi over 2 plus pi over 4. What is the value of lambda? Yes? Yes, can you send back paper, please? So lambda will be minus n pi over 2 plus pi over 4 squared. All right? Right, so this is lambda, and I can put an n because this depends on n. So in this case, the phi n will be cosinus of n pi over 2 plus pi over 4 times x. Right? So, we found the eigenvalue to be this guy, and the eigenfunction to be this guy. All right? Right. So now we're gonna have to expand the solution used. Right. So project U, the solution U, Px onto the basis equal to cosine inverse of n pi over 2 plus pi over 4 x. Right? So now you're gonna have to project, or you're gonna have to expand the solution using this basis. Alright, so I'm gonna write u tx is a1 t v1x plus a2 t v2x, and this can be written like the sum when n is going from 1 to infinity of a n t vnx. Alright? So now we have the basis. We're gonna project the unknown solution onto this basis, which is vnx. So you write utx like a1t v1x plus a2t v2x, etc. This is the shorthand notation for this sum. Questions? Now, what is UTT? Yes?
A double prime of t in this case.
Yes,
Not
can you
t
send
in
back paper, please? So, in order to take this derivative in t, you just take the derivative in all of a, right? So this is written like the sum when n is going from 1 to infinity of a n second t pnx. Alright, so this is UTC. Questions? Right, so now you're gonna have to do uxx, tx. So what is uxx? Yes? Yes, can you send the back paper, please? So to take the derivative in x, you're gonna have to do this, right? A2t, v2 second x, plus, etc. And this is the sum when n is going from 1 to infinity of a n t times vn second x. Right? Right. So can I remove the second derivative of vn? Yes?
Because we already solved it, because we know phi double prime of n is lambda n bn.
Right. Can you send back paper, please? So you know that vn second, right? Vn second is lambda n vn. Right, so you can replace everything here by lambda 1 v1 x plus a2 t lambda 2 v2x plus etc. And this is the sum when n is going from 1 to infinity of a n t lambda n vn. Alright? So now I'm gonna have to multiply with for uxx. So what is 4 times uxx? Yes?
4 times the summation of from n is equal to 1 to infinity of a n t v double prime.
Yes, you can send back paper, please. So you're gonna have to multiply everything here with 4, right? So you have a1 t lambda 1 v1x plus 4 times a2t lambda 2 v2x. And this is the sum when n is going from 1 to infinity of a n t 4 times lambda n vnx. Right? But you know that utt is equal to ux. 4 times uxx. So which means that this guy and this guy, they're equal. Right? You know that utt is 4 times uxx. So what can I say about a coefficient? Yes?
Yeah, and double prime of t is equal to 4 an t lambda n.
Yes, can you sign back paper, please? So, which means that the coefficient of P1 has to be equal to the coefficient of P1. So A1 second has to be equal to 4 times A1 lambda 1. This guy and this guy have to have the same coefficient, right? And which means that this guy and this guy, you have to have the same coefficient, right? Then you have an second is equal to 4 times an lambda n, right? This is because the coefficient here has to be equal to the coefficient here, because they are the coefficient of P1. Coefficient here has to be equal to the coefficient here because they are the coefficient of P2. And in general, an second has to be equal to 4 times an lambda n because they are coefficient of Pn, right? But we know that this lambda n is the guy here, right? So this is minus 4 times n pi over 2 plus pi over 4 square an. All right? So you know what is lambda n, right? We computed lambda n here. So basically, you have an second is minus 4 times n pi over 2 plus pi over 4 square n, right? So now you have a second order differential equation. Differential equation. How do you solve this equation? Yes?
You use the characteristic equation.
Yes, can you stand back paper, please? So we solve by the characteristic equation. Right? What is the characteristic equation of this equation? Yes?
R squared equals 4 lambda.
Yes, can you stand back paper, please? So the characteristic equation will be r squared is equal to minus 4 n pi over 2 plus pi over 4 squared. Right? Right, so this equation has a characteristic equation. The characteristic equation is r squared is equal to minus 4 n pi over 2 plus pi over 4 squared. All right? So this equation has 2 roots. Has 2 roots. Right, so this equation has 2 roots. What are the 2 roots? So you have an second is equal to minus of this guy. So this is the characteristic equation. Yes?
It would be plus or minus I, or 2I square root, or sorry, plus or minus 2I n pi over 2 plus pi 4.
Yes, can you stand back paper, please? So you have the 2 root will be plus or minus I square root of this guy, right? 2 times n pi over 2 plus pi over 4. Right? So this equation is second order differential equation. You solve it like the way you solve the eigenvalue problem. All right? So r squared is minus this guy, which means that you have 2 solutions. First one is I 2 times of this guy, and the second one is minus I 2 times of this guy. Right? So then an of t, what is the form of the solution an t? Sophie?
C1 cosine of R1x, well, sorry, yeah, plus C2 sine R1.
Yes, can you say back please? So this is C1 cosine R1t plus C2 sinus of R1t. Right? Alright? So So this is basically the formula for solution of the second. Yes.
The second was supposed to go to this side.
Sorry.
Sine should be R2.
Yeah, side should be this.
No,
No, sorry. This is wrong, so I have to take the absolute right. Right, so this is the argument. Right, so the argument of R1, so let me write it. So this is C1 cosinus of 2 n pi over 2 pi over 2t plus C2 sinus of 2 n pi over 2 pi over 4t. Right, so you remove all of the I. Can you sign back paper, someone who found my mistake? Right, so when you, this equation has two root, which is plus or minus I square root times this guy. So the general solution should be C1 cosinus of this guy times t, and C2 sinus of this guy times t. Right, so this I have to put an n. Right, and we don't know yet what is C1 and C2. We don't know yet. Yet C1n and C2n. Right, so we don't know yet C1n and C2n, but I can plug it back to this equation. Right, so this is U1n is the sum. When n is going from 1 to infinity of int phi nx, and this is the sum when n is going from 1 to infinity of C1n cosinus of 2n pi over 2 plus pi over 2t plus C2n sinus of 2n pi over 2 plus pi over 2. And then you have a phi n. Phi n is cosinus of n pi over 2 plus pi over 4. X, right? Now you solve and you know what is an. You don't know yet C1n and C2n, and this is your task to find C1n and C2n, right? But you can plug it back to the solution, right? The phi n in this case is cosinus n pi over 2 plus pi over 4x. The ant is C1n cosinus of this guy and C2n sinus of this guy, right? So from here, how can I find C1n and C2n? Yes?
Could we plug in the initial conditions on?
Yes. Can you stand back, please? So now we're going to use the first boundary condition, right? So the first boundary condition said what? This is xt. So the first boundary condition said that ux at 0 is equal to 1 minus x squared over 4. All right? So, right, so now I'm going to plug t to be 0. But ux at 0 will be the sum when n is going from 1 to infinity of c1n cosinus of 0 plus c2n sinus of 0 cosinus of n pi over 2 plus pi over 2x. All right? So this step is to replace t to be 0 here, right? So we have this series, which is quite complicated. We know that ux at 0 is 1 minus x squared over 4. So I'm going to replace t to be 0 here. When I replace t to be 0 here, I get cosinus of 0, which is this guy, right? And sinus of 0, which is this guy. This guy is the same because the t is 0. Questions? It's good. So which means that 1 minus x squared over 4 is the sum when n is going from 1 to infinity of c1n cosinus of n pi over 2 plus pi over 4 x. Questions? Explain again. So after I found the form of an, I solved the characteristic equation to find the form of an, right? But in this form of an, you don't know what is c1n and you don't know what is c2n. You plug it to this equation, you have uxt is the sum when n is going from 1 to infinity of c1n cosinus and c2n sinus times the phi n, right? You know that the initial condition at t is equal to 0 is 1 minus x squared over 4. So you're going to replace t is equal to 0 into this formula, right? So when I replace t to be 0, this cosinus becomes cosinus of 0, this sinus becomes sinus of 0, and this is the same. So the cosinus of 0 will be 1 and sinus of 0 is 0. So here I have c1n. So how can I find c1n? Yes?
I just have a question. Shouldn't it be cosine of 2 times n pi over 2 plus pi over 4?
Cosinus of which one?
At the bottom.
This one?
Yeah, shouldn't there be a 2?
Is it 2 outside?
Yeah.
No. What is the form of the phi n that I found?
It's 2i.
No, the phi n.
It's how you wrote it.
Phi n is
It's because that's the end, and the other ones are.
Oh, yeah, gotcha.
So the phi n doesn't have a 2, right? So,
right, we're talking about the an.
all right, so the an has a 2. The an has a 2,
Yeah.
but this is the phi n, so you don't have a 2. This is phi n x. This is phi n x, right?
Yeah.
So the phi n x doesn't have a 2. Right? Okay. So how can you find c1n? Yes?
The inner product.
Yes, can you stand back paper, please? So all of the phi n, they are orthogonal, so in order to find c1n, you do the inner product. So c1n will be the inner product of 1 minus x squared over 4 with the phi n, which is cosinus of n pi over 2 plus pi over 4x. And then you inner product between cosinus n pi over 2 plus pi over 4x. Cosinus of n pi over 2 plus pi over 4x. Right? So to find this c1n, you inner product 1 minus x squared over 4 with the cosinus and the cosinus with the cosinus. Why is it? Because from here, what you can see is that 1 minus x squared over 4 is c1 1 v1x plus c22 v2x plus c1n c12 c1n vnx, etc. Right? So now I'm gonna inner product everything with vn. Right? So this gives you c11 v1 vn plus c12 v2 vn plus c1n vn. Alright, so this is the standard process, right? Because you have 1 minus x squared over 4 is c11 v1 plus c12 v2 plus c1n vn, right? Now if you inner product this guy with vn, you're going to have c11 v1 vn, c12 v2 vn, c1n vn, right? This goes away because they are orthogonal. This goes away because they are orthogonal. So the left over this guy and this guy, right? So which means that you have 1 minus x squared over 4 vn is c1n vn, which means that c1n is the 1 minus x squared over 4 phi n divided by phi n phi n. Alright, so this is the standard process. Questions? And this is why you have this formula. I explain again. You have 1 minus x squared over 4 is the sum when n is going from 1 to infinity of c1n times phi n, right? Which is this sum here. So you have 1 minus x squared over 4 is c1 1 phi 1 plus c1 2 phi 2 plus c1n phi n. Alright? Now I'm gonna inner product this guy with phi n. So when I inner product this guy with phi n, all of the term here disappear except this guy. So you have 1 minus x squared over 4 inner product with phi n is c1n phi n phi n. So c1n is this guy. Questions? It's good. Now I have to compute. Alright, so I have to compute everything to find c1n. Now I have to compute c1n. So the easy thing is the inner product of the guy from the bottom. N pi over 2 plus pi over 4 x. Right. So what is the definition of this inner product? Yes.
The integral from 0 to 1 of that split.
Yes, can you stand back in the paper, please? So the integral from 0 to 2, because the domain is from 0 to 2. N pi over 2 plus pi over 4 x, and this is the square. Alright, so how can I compute this integral? Yes?
We can also use the identity of instead of 1 minus, it's 1 plus cosine 2 theta over 2.
Yes. So what you do is you use this formula. Cosinus x squared is 1 plus cosinus of 2x over 2. Alright? So you plug it here. You have the integral from 0 to 2 of 1/2 of 1 plus cosinus of 2 times this guy. So this is n pi plus pi over 2 x dx. Alright? So how can I compute this integral? Yes?
No, you just split it.
Can you stand back the paper, please? So I'm going to split it. So 1/2 integral from 0 to 2 of dx plus 1/2 integral from 0 to 2 of cosinus of n pi plus pi over 2x dx. Right? What is the value of the first integral? Yes?
1.
Yes, can you stand back the paper, please? So the first one gives you 1. Now, how can I compute the second one? Yes?
Isn't the second one just going to be 0 because you're going to integrate to sine and sine of 0 and getting 0,
Yes.
and then 2 will cancel out with pi over 2.
Yes. Can you stand back the paper, please? So now I'm gonna take the antiderivative of this guy. So the antiderivative of this guy is sinus, and I evaluate 0 and 2, so the sinus will be 0. So basically the first, this guy is 1. Right? I explain again. The bottom in the product will be the integral from 0 to 2 of cosinus of n pi over 2 plus pi over 4x squared dx. This cosinus square will be 1/2 of 1 plus cosinus n pi plus pi over 2x dx. To compute this guy, I'm going to split it. So the first integral gives me 1. The second integral is cosinus. The antiderivative of cosinus sinus. So I evaluate 0 and 2, and this gives me 0. So basically, the first inner product is 1. Right? Right, so let us compute the second one. So the second one is 1 minus x squared over 4 of cosinus of n pi over 2 plus pi over 4 x. All right, what is the definition of this inner product? Yes?
The interval from 0 to the f of x multiplied by cosine.
Yes. Can you stand back paper, please? So this is going to be an interval, right? So this is cosinus of n pi over 2 plus pi over 4 x dx. All right? So how can I compute this interval? Yes?
The first one's going to be 0, or if you expand it to where you end up with
Can you stand back paper, please?
cosine minus x squared over 4 cosine.
Right, so I have
First is
the first
gonna
one.
be 0.
Yes. So this guy. Right, so minus integral from 0 to 2 of x squared over 4 cosinus of n pi over 2 plus pi over 4 x dx. All right? So I'm gonna split it into two integrals. The first one is the one with the 1, and the second one is the one with x squared over 4, right? So when I do the first one, the antiderivative of this guy is sinus n pi over 2 plus pi over 4 x dividing by n pi over 2 plus pi over 4, and I evaluate at 0 and 2. And the second one is something that I'm going to do it later. N pi over 2 plus pi over 5 dx. All right? So, right, so the first one is easy because the first one I can do the antiderivative of cosinus. That gives me sinus. All right? And I have to evaluate 0 and 2. Right? But this is not 0.
Oh, I did it wrong.
So what is the value of this guy? Yes? Yes, can you sign back paper, please? So this, you evaluated 0, it is 0, but you evaluate 2, you get minus 1 to the n over n pi over 2 plus pi over 4. And then I have to have the second guy, which is x squared cosinus of n pi over 2 plus pi over 4 x dx. All right, so the first one is this guy. Now I have to compute the second one, right? Suppose that I forget about the minus 4, and I just have to compute the integral inside. I have x squared cosinus of n pi over 2 plus pi over 4 x dx. Right? How can I compute this interval? Yes?
Integration by parts.
Yes,
but
and
then
hand back
you-
paper, please. So again, here I have to use the integration by part, right? So integration by part is udv is uv minus v du. All right. So this cosinus is integral from 0 to 2 of x squared sinus of n pi over 2 pi over 4 x prime, over n pi over 2 plus pi over 4, and I have to take a prime dx. All right? It's good. So this is going to be uv prime is uv minus v and u prime. So this is u, and this is prime. All right. So I use the integration by part. I have what? I have uv, which is x squared sinus of n pi over 2 plus pi over 4 x over n pi over 2 plus pi over 4. I evaluate 0 and 2, and then I have to minus interval from 0 to 2 of sinus n pi over 2 plus pi over 4x dividing by n pi over 2 plus pi over 4, and then you have x squared prime dx, right? So the integration by pi is udv is uv minus v du, or uv prime is uv minus v u prime. All right, so here I have u is equal to x squared, and v prime is equal to sinus of n pi over 2 plus pi over 4x over n pi over 2 plus pi over 4 prime. So this is u and this is v prime. So here this is uv, right? And here this is v u prime. All right? It's good. So what is the value of this guy? Yes, Sophie?
Negative 1 to the n divided by n pi over 2 plus pi over 4.
Yes, and then you have two squares inside back paper, please. So the first term is 4 times minus 1 to the n dividing by n pi over 2 plus pi over 4, right? Minus 1 over n pi over 2 plus pi over 4. The derivative of this guy is going to be 2 times x. So the integral from 0 to 2 of sinus of n pi over 2 plus pi over 4x. And then I have 2x dx. All right? It's good. Right, so the first guy, I evaluate at 2 and 0. So at 2, this guy is 2 squared, and so this is 4. This is why here you have 4. At 2, this guy is going to be n pi plus pi over 2. This is why you have minus 1 to the 4. You keep this in this bottom, and then when x is 0, this is 0. The second term, so x squared prime is 2x. So I keep 2x and I keep everything. I put this fraction outside. So because here I have a 2, I can put 2 here. All right. So now I have to compute integral from 0 to 2 of sinus of n pi over 2 plus pi over 4 x times x dx. So I put x here. What can I do next? Yes?
Integration by parts again.
Yes, can you sign back paper, please? So again, here you have to use the second integration by part, right? So this is integral from 0 to 2 of x cosinus of n pi over 2 plus pi over 4 x, and this is minus over n pi over 2 plus pi over 4. And then I have to take a derivative, right? So this will be again my u, and this is again v prime. So I do integration by part, right? So I have x minus cosinus of n pi over 2 plus pi over 4 x dividing by n pi over 2 plus pi over 4. Then I have to evaluate 0 and 2. this is UV. And then I have UV prime, which is minus integral from 0 to 2 of minus cosinus of n pi over 2 plus pi over 4 x divided by n pi over 2 plus pi over 4 x prime dx. Alright? What is the value of the first quantity? Yes? Yes, can you stand back for this? So this guy is 0 because when x is 0, it is 0, and when x is 2, cosinus of n pi plus pi over 2 is 0. So this is 0. The leftover is this one, right? So x prime is 1. So I'm gonna have 1 over n pi over 2 plus pi over 4. The integral from 0 to 2 of cosinus n pi over 2 plus pi over 4 x dx. So I keep this guy. So how can I evaluate this interval? Yes?
It would be everything out front and then sine of n pi over 2 plus pi over 4x divided by n pi over 2 plus pi over 4.
Yes, can you stand
From
back?
0 to 2.
Yes, can you stand back like this? So this gives you sinus of n pi over 2 plus pi over 4x divided by n pi over 2 plus pi over 4 square, and you evaluate at 0 and 2. Alright? What do you get? Yes?
Negative 1 to the n divided by
Yes, can stand back like this. So then you have minus 1 to the n over n pi over 2 plus pi over 4 squared. Alright, so I'm gonna plug this back here. I'm gonna plug this back here. So I'm gonna plug this value back here. So I'm gonna have 2 times minus 1 to the n with this to the power 3. Alright? And then this guy, I'm gonna replace it here. So I'm gonna have 5 times I have 5 times this guy minus 2 minus 1 to the n pi over 2 plus pi over 4 to the power 3, and this is my C1n. Right? Because you divide by 1.
Where did the 5 come from?
So this is one term, right?
Right.
Here I have 1 plus this guy. Remember that? So I have minus 1 to the n over n pi over 2 plus pi over 4 plus this term. And this term gives you 4 minus this guy. So you add up the 2, you get 5. That's good, yes?
Wasn't all of this supposed to be multiplied by negative 1/4, but we just ignored that?
Okay, so so yes. So I think I forgot my minus 1/4, right? So here I have to have, yes, so you're right. So you have minus 1n, right? Dividing by n over 2 plus pi over 4, right? plus minus 1/4 times this whole thing, right? Right, so minus 4 minus 1 to the n over n pi over 2 plus pi over 4 minus 2 minus 1 to the n over n pi over 2 plus pi over 4 to the power 3. Right? It's good. Right, so I didn't make any mistakes, right? So here I have to multiply this guy with minus 1/4, right? And so this guy cancels with the other one, so this gives me minus 1 to the n over 2 n pi over 2 plus pi over 4 to power 3. Alright? This is my C1n. Alright. Split. It's good, right? So this is my C1n. Right, so this is uxt is going to be the sum when n is going from 1 to infinity of C1n of cosinus of 2 n pi over 2 plus pi over 4 t plus C2n 2 n pi over 2 plus pi over 4 t times these big things. So right, so I have cosinus of n pi over 2 plus pi over 4x. And C1n is computed already. So C1n is going to be minus 1 to the n over 2 times n pi over 2 plus pi over 4 power 3. It's good. Now we know what is C1n. The next step is to find C2n. How can we find C2n? Yes?
Use the other initial condition.
Yes.
And I believe C2n is 0 based on that.
Yes, can you stand back paper, please? Right, so C2n is going to be less horrible than C1n. Right, so I'm gonna use the second boundary condition. So to find the second boundary condition, I have to compute the derivative in T of this series. So what is the derivative in T of this series? Yes?
Sum as n goes from 1 to infinity of a prime t
Yes.
times.
Right, so can you stand back there like this? So you're gonna take the derivative of this guy. Right, so this is when going from 1 to infinity of C1n of I don't write explicitly C1n because this is 2 times n pi over 2 plus pi over 4 minus sinus of 2 n pi over 2 plus pi over 4 t. Alright, so this is the derivative of this guy. And then I'm gonna have to take the derivative of the second guy. This is C2n to n pi over 2 plus pi over 4 of cosinus of this is sinus cosinus of this guy. N pi over 2 plus pi over 4 t. And then I have cosinus of n pi over 2 plus pi over 4 x. So, what is ut of x0? So what happened when I replace t to be 0 into this series?
The sum from 1 to infinity of C2n multiplied by cosine n power of 2 plus power of 4x.
Can you send it back paper, please? So you replace t to be 0 here, right? So this gives you the sum when n is going from 1 to infinity minus c1n times 2n pi over 2 plus pi over 4 sinus of 0. Right. And then you have c2n 2n pi over 2 pi over 4 cosinus of 0. And then you multiply everything with cosinus of n pi over 2 plus pi over 4. So this guy is 0, and this guy is 1. So this gives me the sum when n is going from 1 to infinity of c2n times 2n pi over 2 plus pi over 4 times 1 cosinus of n pi over 2 plus pi over 4x. Alright? So first I take the derivative of the series by taking the derivative in t of everything. Right? So now I replace t to be 0 into the series. When I replace t to be 0, this becomes sinus of 0, and this becomes cosinus of 0. Sinus of 0 is 0, and cosinus of 0 is 1. So this gives me 2n times 2 n pi over 2 plus pi over 4 cosinus n pi over 2 plus pi over 4x. This is dt of ux 0. But I know that this is 0. Right? So this is also 0. What can I say about c2n?
It also equals 0.
Yes, can I find paper, please? So because this guy is 0, c2n have to be 0. Right? So c2n, again, you can compute c2n by using the formula that we had before. So you're going to have 0 inner product with c2. So here you have c2n times 2 times n pi over 2 plus pi over 4 is the inner product of 0 with cosinus n pi over 2 plus pi over 4x, and then you inner product of this guy, n pi over 2 pi over 4x cosinus of n pi over 2 pi over 4x, and this is 0. Alright? Because you are expanding 0 to a series, and this means that all of the coefficient has to be 0. This can be seen by the formula that we had before, your inner product. So this coefficient here will be computed by inner product, this guy which is 0, with cosinus and dividing by cosinus. So this inner product is 0. Why this inner product is 0? Anyone else? Who knows why this is 0? You have? Yes?
Because when you take the integral, you multiply the two by together, so you get
Yes.
this.
Can you slide back paper, please? So this is the integral from 0 to 2 of 0 times cosinus of n pi over 2 plus pi over 4 x dx, right? So the inner product is the integral of the product of the two functions, and because you multiply that with 0, the integral has to be 0. Right? So c2n is 0. So now I replace c2n to be 0 here, and I get this is the sum when n is going from 1 to infinity of cosinus of 2 times n pi over 2 plus pi over 4 t times cosinus of n pi over 2 plus pi over 4 x. Right, so this is basically u xt. All right? Yes?
Is that minus the cosine
No, this is the
Okay.
right? So I replace C1n to be this guy and C2n to be 0. So this is basically the solution. To solve this kind of PDEs, you don't have the explicit function, right? You only have series. So those series will not give you any explicit function. Those series will give you only the series, but you can compute that, right? Questions? That's good. Another questions. I didn't check those boundary condition. Why is it? So I check this, I compute C1. From here I compute C2. From here I get the relation between AN and second and AN, right? Why didn't I check these two boundary conditions? Yes?
So those boundary conditions have already been proven with our U double X equation and our basis, and those are true regardless of what value T holds.
Right. Can you stand back paper, please? Right, so I didn't check the boundary condition because of the way we choose the phi n, right? So I didn't check the boundary condition because we choose phi n to be satisfying those boundary conditions, right? So you have phi n at 0 is 0, and phi n at 2 is 0. So this is the way we choose the eigenvalue problem. So this boundary condition is chosen here, and this boundary condition is chosen here. So when you write uxt and the sum, when it's going from 1 to infinity ant, phi n x, this is our series, right? So the ux xt will be the sum when n is going from 1 to infinity of ant phi n prime at x, right? Now I replace 0. This is going to be this, and this is 0, right? This is 0 because this is chosen here. So basically you have 0. Alright? I didn't check because I chose the boundary condition that way for the eigenvalue problem. And when I do the expansion, I have uxt is somewhere n is going from 1 to infinity of ant phi n x. I want to see what is ux at 0. So I take the derivative in x, which gives me phi n prime, and I replace x to be 0. I get phi n prime is 0, but phi n prime is 0, so I have a series of zeros. So this is 0. Similarly, for phi n u2t can be computed the same way. So I have the sum when n is going from 1 to infinity of ant phi n2, and this is again 0. This is 0. So you have the sum of all of the 0, and this is also 0. So basically, because I chose that, I don't need to check the boundary condition because it's automatically 0. Questions? Yes?
So if the boundary conditions were not set equal to 0, would you have to check them then?
And if the boundary conditions are not 0,
Yeah.
then it's a different story. So you have to solve two different problems. First, you have to solve a problem with 0 boundary condition, and then you have to find a solution which is, you have to find a particular solution which has no 0 boundary condition, and then you add up the two. But this is too difficult. I'm not going to ask you to solve this kind of problem. Other questions? It's good. So tonight I'm gonna post the final project. So basically, what you have to do is to solve 3 problems, and you have to submit. You have to type them, right? So if you write by hand and take a picture and send it to me, I will not accept it. So you have to type them. So those are easy problems like this, right? right? But you have 1 month to do it, and you have to send it by December 16, which is the schedule final exam date, right? By 5 p.m. and you send it to me by email, right? You cannot solve. I mean, so if you send me, if 2 students send me the same exam, I mean, if 2 students send me the same solution, you will both get 0, all right? So you have to solve those problems separately. I mean, you can collaborate, but you have to write differently, right? Questions? So those will be the heat equation and the wave equation, and they're like this. Right? So it's not going to be difficult. All right. So let us go to another example. Alright, so let us solve another key wave equation. So you have this, and then x is going from 0 to 2 pi, and t is going from 0 to infinity. Alright, so I'm going to change the initial condition. So u0 at t is going to be 0, u x as 2 pi, t is going to be 0, and then you have u x0 is going to be 0, ut x 0 is going to be 0. So in this case, the solution u is uxt. Right, so in this case, you have another wave equation, all right? You have utt is equal to uxx, x is from 0 to 2 pi, t is from 0 to infinity, u is a function of x and t. So this is a wave equation because you have the second derivative in t and the second derivative in x. The two boundary condition will be 0, so u0 t is 0 and ux 2 pi t is 0. The initial condition will be 0. So, can you tell me what is the solution of this equation? Any guess? You can see the solution right away. Yes?
Is it a sine function?
What?
Is it a sine function?
No, not a sine function.
Is it 0?
It's 0, yes, you can say by purposes. So for this equation, the solution is 0. But we're going to use the method and we check that this is 0. Alright? So you see that, okay, if you choose 0, the second derivative of 0 is 0. The second derivative in t of 0 is 0. The second derivative in x of 0 is 0. This is 0, this is 0, this is 0, 0, right? So solution is 0. Right, so, but let us try to prove that this is 0, all right? So eigenvalue problem. All right, so you have phi second is lambda phi when x is from 0 to 2 pi. What are the two boundary conditions for the eigenvalue problem? Yes?
If 0 equals 0 and
or well, phi of 0 is 0 and phi prime of 2 pi is 0.
Yes, can you say it back paper please? So phi of 0 is 0 and phi prime at 2 pi is also 0. This is the eigenvalue problem that we have to solve. Alright? So basically we don't have any more homework, but the points that you have for answering questions in class will be added to the final in the following way. So if you have one extra point, in the final you will be added 1 over 4 point, right? So if you answer 4 questions, you will be added 1 extra point to the final, right? And the total points of the final will be 25. So if you don't want to do the final, you have to answer 100 times. All right, so let us solve this eigenvalue problem. How do you solve this eigenvalue problem? Yes. Yes.
Use the characteristic equation.
Yes.
Or square is like that.
Yes, can you say back paper please? So the characteristic equation will be r squared is equal to lambda. It's case number 1. Lambda is positive. What happens when lambda is positive? Yes?
You have to
What are they?
square root of lambda and minus square.
Yes, can you say back paper please? So the two root will be plus or minus square root of lambda. Alright? So what is the form of the solution? Yes?
C1 e to the square root lambda x plus C2 e to the negative square root.
Yes, can you say back paper please? So in this case, you're gonna have Px will be C1 into the square root of lambda x plus C2 e to the power minus square root of lambda x. What is the next step? Yes? Yes, can you say back paper please? So we have phi0 is 0, which means that C1 e to the 0 plus C2 e to the 0 is 0, which means that C2 is minus C1. So the Px will be C1 is square root of lambda x minus C1 e minus square root of lambda x. Alright? What is the next step? Yes?
Take the derivative.
Yes, can you say back paper please? So I'm gonna take the derivative. This gives me C1 square root of lambda is square root of lambda x plus C1 square root of lambda e minus square root of lambda x. Alright? And then I'm gonna plug the boundary condition, right? So I have phi prime at 2 pi is 0. C1 square root lambda e square root lambda and 2 pi plus C1 square root lambda e minus square root lambda and 2 pi is 0, which means that C1 is 0. Alright? So in this case, you don't have anything. We will continue on Tuesday.